Why digital design and visualization, especially why 3D computer graphics? Our course title is Digital Design and Visualization. Why visualization matters? Simply say, very pragmatic, very practical reason for enhancing your design visualization skills. Okay? How to enhance your design technique, design representation techniques. Another one, for moving forward to advanced design computing issues such as BIM. Okay? You have to know geometric modeling first and then move to information modeling approach, BIM approach, and even more advanced approaches. Okay? Main focus is here, enhancing your design representation, design visualization skills. Okay? Let's briefly take a look again, history of computer design. History of CAD is a history of how to understand design. What is design? Okay? Around 50 years ago, when the Sketchpad, the first CAD system, okay, line drawing CAD system, computer system, invented, at that time, people believed that the design is a drawing of the product. That is why we are focusing on elevation, plans, perspective, or something, line drawings, okay? So geometric drafting in 2D was the CAD system at the time. But some smart people invented 3D surface-based model approach, okay? Surface-based 3D representation. It's 3D, okay? You can rotate this box. You can see top view, front view, section, and so on. Geometric surface modeling in 3D. That is so-called surface-based 3D model. Even smarter people suggested and implemented 3D solid modeling approach. Why solid? Think about this one. Surface-based 3D looking object, looking 3D. But surface doesn't have thickness. In other words, it's mathematical definition, not real object. But can you find zero thickness object in real world? There is nothing. There is nothing like that. In other words, in real world, even if it's very, very thin or very lightweight, anyway, it has thickness. It has weight, okay? So we need to solid fill in the definition of geometry. So that is solid model, realistic, okay? Even smarter people suggested and invented the parametric model. Okay, point line, they are all mathematical definition, something abstract, something unreal. It's not realistic. In real world, we are using width, depth, thickness, height. What if you want to control this one? Change higher height, and then this one going to be updated, okay? Not controlling vertices or lines and so on. The most advanced one is here. Entire rest of things are the part of this one. More information. What kind of information? Compositional, analytical, and fabrication representations of the product going to be part of this model. So that is building information modeling. This semester, we are still focusing on this one. What if you use only 2D CAD tools, 2D drawing tools? That's going to be here, but thankfully, we are here. But the problem is, it's exactly the same to SketchUp. But lots of powerful and predefined, well-defined aspects of design visualization things in 3D Max and related tools. So this is the focus of this semester. How about next semester? Rest of things, and this one also one part of the next semester's digital design and BIM course, okay? Anyway, this is the scope of this semester. Some part of others, of course, the subject, but not the main. Anyway, my point is here, okay? Let's quickly review design mode we have learned before. Very simple. Mode of thought, your brain. No one can see your brain, okay? What is inside of your head, okay? It's not possible. Before you are saying something, you are drawing something, you are creating some computer file, visualization, or something else. Before doing that, no one can see your idea, but it's very still important to you guys. Take a look at the description. Next one is mode of expression, something to be visualized. Final stage, of course, mode of production, okay? No need to say. Anyway, take a look. Visual equivalent. Visually equivalent to your design concept, design idea, design approach, okay? Visualization is the most important thing you need to achieve in your design expression mode, okay? How about design media? Designed by hand for several thousand years. Compared to human history, more than 99% of history used hand drawing, okay? Pencil or pens, whatever it is. But in this class, we are using computers. But I told you, just 40, 60 years ago, computer has invented CAD systems, just 40 years, okay? Your computer tool, 3D Max 2015, released 2 years ago, okay? Anyway, we're gonna use computers. Designed by pencil to computing, that's the change we encountered. The pencil is the most basic media of design. Nowadays, you can simply, quickly draw by hand for your design, okay? That's your kind of primitive idea sketch or something. But this is design computing course. We have lots of IT, lots of technologies. We're gonna use new media. That's why I call digital design media, okay? You have to maximize the effect, the power of your media, okay? Your media in this room, in this class, of course, it's computers. You are using smartphones, tablets, some mobile devices, mostly for fun or for communicating with friends. But anyway, you can use some IT tools for your design, something productive things. Here is an example, student work, freshman work, okay? Freshman work. They didn't know any computer software for design, but they have learned SketchUp, V-Ray, some renderers, Photoshop, and they could make this kind of visualization. How about this one? Jewish Museum, Slipbox, something not 100%, but anyway, looking realistic visualizations. Line stroke, SketchUp, visualization styles. I assume that you are already well known to design visualization using Rhino, AutoCAD, SketchUp, V-Ray. But in this semester, 3D Max Design and Autodesk Material, Mental Ray, some technical aspects regarding such tools and Autodesk tools, some primitive introductory things about Autodesk Revit, and so on, okay? That's the scope. Last week, I showed you this one before. What you have to learn are listed up here. Some great phones, hardware, internet, software, operating systems, some fundamentals in engineering theory. But anyway, focus on fundamentals in the lecture. In the lecture, I'm gonna let you know what is the critical fundamentals of design computing theories, okay? We have midterm exam, November 21st. Regarding my lecture, okay? Based upon my lecture, you're gonna have the exam. In the lab exercise hours, I told you again and again, 3D Max Design, Mental Ray, V-Ray, Photoshop, Intro to Revit, and possible some more applications. it's up to you. Anyway, that's the subject for the lab exercise. Even more things about design computing, such as 3D printing. In this semester, you're gonna be asked to print something. Create something by 3D Max and print them out using 3D printers. Laser scan, photogrammetry, virtual reality. They are one of the subjects we're gonna deal with in this semester, okay? Let's take a look at this 3D rendering, okay? This is kind of very famous image, okay? This is not a picture, of course, it's a computer-generated image, render image. So if you click this, you can find out some website link. 3D rendering on the Wikipedia. There is the image, okay? Actually, it's not important, but anyway, Gill's trend with Ray using radiosity. Radiosity is one of the technologies available nowadays in photorealistic rendering, something like this. Even if it's not kind of 3D Max generated, anyway, by using 3D Max and recently developed technologies, you can make this kind of visualization. Even today, actually. But anyway, lots of more and sophisticated handling you need. But my point here is, nowadays computer visualization technique is very, very advanced. What you need to do is take maximum advantages of existing techniques, okay? Is this a picture or computer graphic? Or it doesn't matter? My answer is it doesn't matter, okay? Of course, this is computer generated. This is IKEA product. No matter what it is, no problem, because visualization nowadays, there is no difference between real picture and computer generated. Sometimes computer generated looking much realistic than pictures. Anyway, take a look this interior. Some type of office layout. Is this a picture? Of course, it's computer generated. How about this? Kitchen area. Computer generated. IKEA. IKEA provides you lots of some PDF file or online brochure or even print out brochure for their products using computer graphics, okay? Not real product. Why they made this kind of computer graphics? Take a look. Same product, IKEA product for kitchen, okay? Kitchen cabinets. But IKEA is kind of global company. Something for Northern America, something for Asia market, something for European style market. Some different faucets, different layouts, a little bit different things fit to local environment. What if they have to take pictures for all of them? They have to remove and reinstall, take picture again and again. But thanks to computer graphics, they made them instantly, okay? Much cheaper than real picture. So take a look. This guy, I'm not sure he's working in there. Anyway, he's in charge of making this kind of real visualization. If you click this link, I just placed a reference for this one, okay? In the Visual News website, take a look, the image that I show you, okay? Okay, 75% of IKEA product photographs are actually computer generated, okay? The chair I show you and the reason why they use this kind of computer graphics and so on, okay? So, in this class, like this guy, we are going to use 3D Max Design 2015 because it's the latest version in design model, okay? Not 2016 or 17, 2015. V-Ray, Photoshop, NVIDIA Mental Ray. Do you know what is NVIDIA? The company name NVIDIA is very, very familiar to gamers. If you're playing game, you may know NVIDIA. NVIDIA GeForce, have you heard of GeForce graphics card? The GeForce graphics card is one of the faster computer graphic system and computer graphic GPU, engine, GPU, cardboard for computer graphics, okay? Anyway, the company NVIDIA bought Mental Ray, and Mental Ray is NVIDIA software. Anyway, thanks to Mental Ray and amount of well-defined professionals material in Autodesk material, you can make very photorealistic renderings and so on. Take a look. This one is actually not 100% photorealistic, but anyway, looking photorealistic, okay? But actually, I made this image in 3 minutes in 3D Max. Just 3 minutes you need, okay? Place cylinder and cylinder extraction in order to make this one is looking glass. Plane and torus knot, lights, render. And you can get this kind of image. How about this one? Last week I showed you similar example. Teapot with ceramic material, floor plane using wood floor, chrome balls, and 3 lights. 2 white color lights, actually 3 lights and 1 yellow color lights, okay? But the dark black background, simply because the background of this image, just nothing, just black background. That is why this one reflects black, okay? So just 5 minutes for making this visualization. My point here is computer graphics, rendering technique, really advanced. Take a look, this example, computer graphics, another computer graphics, even by using SketchUp, easy to use application SketchUp and V-Ray, you can make this kind of scene, okay? That's my point, very easy to use. But I show you actually very photorealistic images. Is your photorealistic visualization always top priority? What I mean is, photorealistic rendering is always your top priority? My answer is, of course, no, okay? Your idea from your brain composed of your computer model, computational model, 3D Max file, SketchUp file, Rhino file, Revit file, whatever it is, and then it's going to be visualized, lots of visualization. So what should be realistic? Your sketch, your 3D, your picture, your animation, sometimes they are visual, photorealistic. But I told you, there is intermediate computer model. So your computer model is supposed to be realistic. In other words, you should try your best for making your computational model, intermediate model, realistic, not the outputs, okay? Without this model, directly from your brain, from your idea to this outputs, very recursive, very time-consuming, tedious, never-ending task you have to do, okay? Your computational model is kind of very realistic and well-made. Your output sometimes line drawing, shaded, sometimes photorealistic rendering, sometimes very nice representation, sometimes very abstract, line stroke based images, sometimes floor plans, and so on, okay? Semantic integrity, that is the thing, the concept you have to be aware of. For your building model, for your computational model, that one has your mini world. What is world? What is universe of this course? What is EOD? Your definition of your world, okay? Okay, when you design your building, think about you are designing your home, your new house. Is there Star Wars characters? Is there some other buildings? Is there some how can I say, some monsters in your universe of discourse? Of course not, okay? Your well-defined universe first, and your object of your interest supposed to be same to your real-world object, okay? This is semantic integrity. Semantically same with your real-world object you are pursuing in terms of your mini-world, in terms of your university of discourse. This university, sorry, not university, it's universe, okay? This universe doesn't need to be same to real-world universe. Real-world universe, what is this? What is that? This university. This one contains anything. This one has 100% things we created. What Mother Nature, also one part of it. Anyway, well-defined your mini world, your universe, that is the important thing you need to take care of. Semantics. This CAD model looks very just line drawing and color shade, that's it. But this one is photorealistic. Which one is better? In terms of visualization, this is looking better. But what if this one has any related information, but this one has amount of information, data, on top of this image or behind this image? This one has semantic integrity, okay? Semantics. So, photorealistic visualization is not always the solution. Architecturally effective visualization, which has semantic integrity, is of importance. That's the topic. That's the thing I like to emphasize. Okay? Let's quickly review something about rendering. Actually, you have learned rendering aspects before. 3D visualization by computers. Let's take a look. Rendering is all about lights. Okay? Okay, take a look. The series of very simplified image. How about this one? Is this rendering? Is this rendering? No? Why no? This is rendering, okay? This is rendering in line stroke style. I told you, rendering, what is rendering? What is the literal meaning of render? If you open dictionary and find out render means visual representation by hand, by some type of media, whatever. So this is rendering, but not photorealistic. It's line stroke render. How about this one? Color fill render. How about this? Shaded with shadow casting. How about this one? Entire thing with texture map. How about this one? Ray traced. Okay? So something advanced, but anyway, all of those visualizations are rendering. Photorealistic is here, but anyway, they are still effective render, okay? Line stroke render and so on. The right text here simply explains you something about computer rendering. Three main things: lighting, your object, camera, okay? Lighting, very important, but SketchUp, Rhino, 3D Max, they have their own default light. But default light is super low quality. That is why you need to place your own light system, because they have much better quality. Anyway, you need to know something about light. Also, you have to know something about camera. It's exactly same to real world camera. If you are very well known to DSLR camera, it's very good, very applicable to real camera object in 3D Max or some other tools. Camera is still very important. How about object? Of course, it's really critical. Your object, what is diffuse? The surface color, surface material, as it's seen by your eyes, okay? Intensity, texture map, shadow casting, ambient occlusion, lots of sub-objects, sub-things you have to know. Reflection, refraction, caustics, lots of things you need to know. How many? Take a look, this one. You have to know those technical keywords for computer rendering. But no worries, not that complicated. Even if it's looking complicated, if you understand the mechanism, nothing. And another good news is, this is something about V-Ray in SketchUp you have learned last year. In Mental Ray, there are amount of presets. Preset means predefined material. Defined by whom? Student? No. Experts. Some professionals already defined to provide you this kind of thing. You don't need to worry about those things. Today's lab exercise, you will find out how it is easy to use and powerful. Okay? Take a look this one. Lighting source, reflection, but no caustics. This is caustics, okay? And take a look. Some type of ambient occlusion. This is ray tracing, okay? There is a ray, okay? Ray penetrating this glass make another lighting effect like this. Reflection from this green color, but there is no green effect. This is not ray tracing, okay? This is radiosity-based ray tracing technology applied. Something like Mental Ray. Anyway, as a default, we're going to use Mental Ray. We use this one, okay? Very powerful preset renders and very powerful Autodesk material. That is what you're going to use today, okay? Okay, let's finish the lecture and move to the lab exercise, installation and quick preview.